Hello friends, in the last video we have solved the example from question number 3 from exercise 1.1. Means we have started exercise 1.1 and from question number 3 we have completed first 5 examples. Now we are solving question number 6. In this question number 6, observe the given function. Here two terms are connected by what? Plus. So means we have to solve the example applying addition rule. So differentiate it with respect to x. So dy upon dx is equal to. So according to addition rule, first find out derivative of first function. If you will observe first term, it is in the form of cos f of x. And what is derivative of cos f of x will be minus sin f of x into f dash of x. Means its derivative will be equals to minus sin f of x. What is f of x here? Root x into derivative of f of x means derivative of root x. Plus keep it as it is. Now we are finding derivative of this term. If you will observe this function, it is in the form of under root f of x. So it is in the form of root f of x. According to that formula, this whole term will be f of x. So its derivative is 1 upon 2 root f of x. What is f of x here? Cos root x into derivative of f of x. What is f of x? Cos root x. So which is equals to, now keep this first term minus sine root x as it is. We are finding derivative of root x. What is derivative of root x? 1 upon 2 root x. Plus keep it as it is 1 upon 2 under root cos root x also as it is. Now we are differentiating it. Now, but if you observe this function, it is in the form of cos f of x, and derivative of cos f of x is what? Minus sin f of x into derivative of f of x. So its derivative is minus sin f of x. What is f of x? Root x into derivative of f of x. F of x is what here? Root x. So which is equals to, already differentiation of first term is completed. In the numerator we are getting minus sin root x, and in the denominator we are getting 2 root x. In the numerator here plus into minus will become minus, sin root x into 1 will be sin root x. In the denominator 2 under root cos root x, keep it as it is. Lastly we are finding derivative of this root x. What is derivative of root x? 1 upon 2 root x. Now differentiation is completed. Let us simplify it. So which is equal to, in this case in the numerator minus sin root x, keep it as it is. In the denominator 2 root x also as it is. Here minus as it is, 2 2s will become 4. In the denominator we will get 4, and remaining term is in the form of root a into root b. Root a into root b can be written as root ab. A is what here? X, and b is what here? Cos root x, and in the numerator 1 into sin root x will be sin root x. Now nothing is there to simplify it, so keep it as it is. So this will be the derivative of this given function. So let us try to find out derivative of this function. So now in the 7th example, given function is y is equals to log of sec 3x plus tan 3x. Means the given function is in the form of log f of x. This whole term is f of x. And what is derivative of log f of x? Log f of x is 1 upon f of x into f dash of x. Here also derivative of log f of x to the base is 1 upon f of x into log a into f dash of x. So will be the required differentiation. So apply this formula, log f of x. So its derivative is 1 upon f of x. What is f of x here? Sec 3x plus tan 3x into derivative of f of x. F of x is nothing but here sec 3x plus tan 3x. So which is equals to, keep this first term 1 upon sec 3x plus tan 3x, keep it as it is. Now we are finding its differentiation. Here two terms are there connected by plus. So according to addition rule, first find out derivative of first term. First term is in the form of what? Sec f of x. This term is nothing but in the form of f of x. Sec f of x. What is the derivative of sec f of x? Its derivative is sec f of x into tan f of x into derivative of f of x. So derivative of sec f of x is sec f of x into tan f of x into derivative of f of x, where f of x is nothing but 3x plus. Now second term is in the form of tan f of x, and derivative of tan f of x is sec square f of x into derivative of f of x. So sec square f of x is here 3x into derivative of 3x. So which is equals to, so in the denominator keep this sec 3x plus tan 3x as it is. Now here sec 3x into tan 3x, keep it as it is. What is derivative of 3x? 3. So 3 we are writing here. Again in the second term also derivative of 3x will be equals to 3. So 3 into sec square 3x will be 3 sec square 3x. So which is equals to, in the denominator keep this term sec 3x plus tan 3x, keep it as it is. Now from these two terms, observe these two terms very carefully. Can I take 3 sec 3x, 3 sec 3x common from these two terms? If we are taking 3 sec 3x common from the second term, what we'll get here? Sec 3x from the sec square 3x. If we are taking sec 3x common, and 3 also we have taken common, so here remaining term is sec 3x. And here if we are taking 3 into sec 3x common, so remaining term will be tan 3x. Now if you observe it very carefully, these two terms will get what? Cancel. And what is remaining term? Remaining term will be 3 sec 3x, and this will be the required differentiation here. Now let us try to solve the next example, example number now 8. If you observe the given function, it is in the form of u upon v. But if you observe this function very carefully here, x degree appears here. X degree means here angle is not measured in radian. If nothing is given here, it is considerable that angle is measured in what? Radian. But here angle is measured in what? Degrees. And hope you remember one important result to convert degree into radian, that 1 radian, to convert degree into radian we are multiplying by what? Pi by 180. So to convert degree into radian. So using this relation, lastly we will convert degree into radian. So now as is said, we are solving this example applying quotient rule, means example is in the form of u upon v. Our this quotient rule says that according to this rule, first keep v as it is. This is u and this will be your v. Keep v as it is. V as it is means 1 minus sin x degree as it is into derivative of u. What is u here? 1 plus sin x degree. V as it is, derivative of u, minus u as it is. What is u here? 1 plus sin x degree as it is into derivative of v. V is here 1 minus sin x degree divided by v square. V square means what? Square of 1 minus sin x degree whole bracket square. Now just simply we have substituted the values in the quotient rule. Now we are simplifying it. So which is equals to, in the denominator keep this term as it is, 1 minus sin x degree raised to power 2, keep it as it is. So keep this first term 1 minus sin x degree also as it is. Now we are finding its differentiation. Derivative of 1 is what? 0. Not necessarily write 0 here. Derivative of sin x degree will be, means it is in the form of sin f of x. And what is derivative of sin f of x? Will be cos f of x into derivative of f of x, where f of x is nothing but x degree here. Again here 1 minus sin x degree, keep it as it is. Here also we are finding differentiation of this term. Derivative of 1 is 0, keep this minus as it is. Now it is in the form of sin f of x. Derivative of sin f of x is cos f of x. What is f of x? X degree into derivative of f of x, means derivative of x degree. In the denominator already we have written here. So which is equals to 1 upon, keep this 1 minus sin x degree raised to power 2 in the denominator as it is. So which is equals to 1 minus sin x degree, keep it as it is, sin x degree. Here cos x degree also as it is. Now to find out this differentiation, first we are converting degree into what? Radian. So for that purpose we are multiplying here by 1 pi upon 180. If we are multiplying by pi upon 180, degree will get converted into radian. So here we will get pi upon 180. We are multiplying to x by pi upon 180. At that time degree will get converted into radian. So not necessary to write radian here. If we are not writing any unit of measurement, so it is considerable that angle is measured in what? Radian. Use the same method here. Keep minus as it is, 1 minus sin This minus into this minus will become plus. Sin x degree, keep it as it is. Keep this cos x degree also as it is. And derivative of d by dx. To find out this differentiation, again we are converting degree into radian. What is the value? How to convert degree into radian? Multiply to it by pi upon 180. So here we will get pi x upon 180 to convert degree measure into what? Radian measure. So which is equals to, now in the numerator 1 minus sin x degree, keep it as it is. Here what we will get, cos x degree into, we know that whatever will be the coefficient of x will be its derivative. So here coefficient of x is pi upon 180. So here its derivative will be equals to pi upon 180 plus 1 minus sin x degree, keep it as it is. Here this cos x also as it is into pi upon 180. So derivative of this term we are finding is differentiation, and we know that coefficient of x will be its derivative. In the denominator 1 minus sin x degree raised to power 2, keep it as it is. Now whatever the denominator is there, we are taking it on one side. 1 minus sin x degree raised to power 2, keep it as it is. Now if you observe both the term, can I take cos x degree into pi upon 180, cos x degree into pi upon 180 common from these two terms? So let us take pi upon 180 common from both the term, pi upon 180. Even we are able to take cos x degree common from both the term, cos x degree common from both the term. So here remaining term will be, so what will the remaining term here? 1 minus sin x, 1 minus sin x degree, and here remaining term will be plus 1 minus sin x degree. Now just a minute, here instead of minus plus is there, here plus is there. So here also we will get plus, here also we will get plus, and here also we will get plus. By mistake we have written here minus. Try to understand, here plus is there, here also we will get plus, here also plus, and lastly here also plus. Now which terms will get cancelled here? Here this plus sin x and minus sin x will get cancelled. Which are the remaining term? 1 plus 1 will be equals to 2, and 2 will get cancelled with this 180. If we will get cancelled with 180 means what we will get here? 90. So means after simplifying it, in the denominator we are getting 90 and 90 into. So what we will get here? 90 into 1 minus sin x degree raised to power 2, and in the numerator what we are getting? Cos x degree, and this will be the required differentiation here. So here in the numerator pi into cos x is the remaining term. In the numerator here we are getting? Pi into cos x degree. So well, now let us try to solve the next example. In the next example here two terms are connected by what? Minus. Means to find out differentiation we have to apply subtraction rule. According to subtraction rule, first find out differentiation of first term, minus keep it as it is, then find out derivative of second term. So well, first now we are finding derivative of first term. If you observe this first term, is it in the form of cot f of x? And what is the derivative of cot f of x? Minus cosec square f of x into derivative of f of x. So derivative of this cot f of x will be minus cosec square f of x. What is f of x here? Log x upon 2 into derivative of f of x. What is f of x here? Log x upon 2. Now minus keep it as it is. Now we are finding differentiation of second term. If you will observe second term, it is in the form of log f of x, and we know that derivative of log f of x is 1 upon f of x into f dash of x. So its derivative is 1 upon f of x. It is in the form of log f of x. So its derivative is 1 upon f of x. What is f of x here? Cot x upon 2 into derivative of cot x upon 2. So which is equals to minus cosec square log x upon 2, keep it as it is. Now we are finding its differentiation. If you will observe this function very carefully, 1 by 2 is a constant term. So keep it as it is, 1 by 2, keep it as it is. And what is derivative of this log x? Derivative of log x will be equals to 1 by x. Means differentiation of this whole term is 1 upon 2x. 1 by 2 is a constant term. We have taken it on one side. And what is derivative of log x? Derivative of log x will be equals to 1 by x. Here minus cot x upon 2, keep it as it is. Now we are finding its differentiation. Here also 1 by 2 is a what? Constant term. Take it on one side. 1 by 2, keep it as it is. Now we are finding derivative of cot x. And we know that derivative of cot x will be minus cosec square x. Okay. So here 2 and 2 will get what? Cancel. So which is equals to, here minus, keep it as it is, 1 upon 2x. I am writing here 1 upon 2x. And remaining term is in the numerator is what? In the denominator we are getting 2x, and in the numerator we are getting cosec square log x upon 2. Here minus into minus will become plus. If we are taking reciprocal of cot, means 1 upon cot will be equals to what? Tan x. And keep this term cosec square x as it is. Again observe, this minus into minus will become what? Plus. Reciprocal of cot will be tan, and this cosec square x as it is. So this will be the derivative of this function. So well, this is our given function, and now we are differentiating it with respect to x. So if you'll observe in 10th example, given function is in the form of u upon v. Instead of directly applying quotient rule, first we will simplify this equation. To simplify this equation, here if you observe the numerator and denominator very carefully, e raised to power minus 2x is there, means negative power is there. So we are able to eliminate this term. If we are multiplying to e raised to power minus 2x by e raised to power 2x, see what we will get here. Here base are same. Since base are same, we are able to take the addition of power. Minus 2x plus 2x will become what? 0, and any number raised to power 0 will be equals to what? 1. So getting it, if we are multiplying to e raised to power minus 2x by e raised to power 2x, we will get what? Plus 1. So let us multiply to numerator by e raised to power 2x. If we are multiplying to first term, means e raised to power 2x into e raised to power 2x. If base are same, take the addition of power, it will become e raised to power 4x. So here if we are multiplying by e raised to power 2x, so here we will get e raised to power 4x. And if we are multiplying here by e raised to power 2x, here we will get minus 1. Since we are multiplying to numerator, that's why multiply to denominator also by e raised to power 2x. Multiply here by e raised to power 2x. So here we will get e raised to power 4x plus, and if we are multiplying here by e raised to power 2x, we will get 1. So plus 1. Now let us simplify this function. Now to find out its differentiation, we are applying quotient rule. According to quotient rule, so first keep v as it is. V as it is means e raised to power 4x plus 1 as it is into derivative of u. What is u here? E raised to power 4x minus 1 minus u as it is. U as it is means e raised to power 4x minus 1 as it is into derivative of v means e raised to power 4x plus 1 divided by v square. V square means square of e raised to power 4x plus 1. Now just simply we have substituted the values in the quotient rule. Now let us try to find out differentiation of these two terms. Keep remaining terms as it is. So here in the denominator e raised to power 4x plus 1 whole bracket square, keep it as it is. Keep here e raised to power 4x plus 1 also as it is. Now we are finding its differentiation. Here two terms are there. First find out derivative of first term. First term is in the form of e raised to power f of x. What is derivative of e raised to power f of x? Derivative of e raised to power f of x is derivative of this e raised to power f of x is e raised to power f of x into f dash of x. So derivative of e raised to power f of x is e raised to power f of x into derivative of f of x. F of x is what here? 4x. And derivative of this minus 1 is 0. Not necessary, write 0 here. Minus e raised to power 4x minus 1, keep it as it is. Now we are finding its differentiation. Again the first term is in the form of e raised to power f of x. So its derivative is e raised to power 4x into derivative of 4x. And the derivative of this plus 1 will be equals to 0. So which is equals to in the denominator e raised to power 4x plus 1 whole bracket square, keep it as it is. Here e raised to power 4x plus 1 as it is. What is derivative of 4x? 4. And 4 into e raised to power 4x will be 4 e raised to power 4x minus e raised to power 4x minus 1, keep it as it is, e raised to power 4x minus 1 as it is. Now we are finding differentiation of 4x. What is derivative of 4x? 4. And 4 into e raised to power 4x is 4 e raised to power 4x. Now if you will observe these two terms, can I take 4 e raised to power 4x, 4 e raised to power 4x common from both the term? If we are taking 4 e raised to power 4x common from both the term, here remaining term will be equals to e raised to power 4x plus 1, and here remaining term will be minus into e raised to power 4x minus 1. Simply we have taken 4 e raised to power 4x, 4 e raised to power 4x common from both the term. In the denominator e raised to power 4x plus 1 whole bracket square, keep it as it is. Now let us simplify the numerator. Observe the numerator very carefully. Here 4 e raised to power 4x, keep it as it is. Now if we are, after opening the bracket, see what we will get. This plus e raised to power 4x and minus into e raised to power 4x means minus e raised to power 4x, and plus e raised to power 4x will get cancelled. Now collect the numerical value. 1 and minus into minus 1 will be plus 1, means 1 plus 1 will be 2. So here we are getting 2. And in the denominator e raised to power 4x plus 1 whole bracket square, keep it as it is. So which is equal to 2 4s are 8. 8 into e raised to power 4x, keep it as it is. In the denominator e raised to power 4x plus 1 whole bracket square also as it is. So this will be our required differentiation here. So in the next video, we will discuss remaining example from question number 3. Again using same formulas and same rules we have to solve those examples.